Hello there. In this short video, I would like to go through one example in chapter 3.1. This is almost the same example as example 4 as we had in class. So let's go there and look at it. So I chose some nicer number here. So instead of 5, I put 4. So you can take a square root and get a nice number. So this is the same problem except I changed that number. So we went through this in class, so let's quickly review it. So in order to find the general solution, you need to set up the characteristic equation. We all know how to do it. You set it up, r squared minus 4 equals to 0. So in this case, you find the two roots. They're nice numbers. That's -1 and -2 and +2. And you can form the general solution, which is a linear combination of these two exponential functions. Okay, now let's look at the second question. It says, now I give you initial condition. So y at 0 is given and y prime at 0 is also given. And then this is a, it's a parameter, so you can change it to see the effect of this number on the solution. So the question here is for you to find value or values of a such that your solution will remain bounded asymptotically, meaning as time goes to infinity. Okay, so how do you achieve that goal? So what we did in class was we start from the general solution and we plug in the two initial conditions and we find out these two constants, C1 and C2. So in the expression of these two constants, you would have this parameter a in it. It's called in terms of a. And then we argue that in order to have the solution bounded, this term here must be 0, meaning C2 must be 0. So you can look at the expression of C2, which has a, and set it to be 0 and find the a. Well, there's another way of looking at the same question. That is, you could start from this observation. Okay, so let's go to the next page and look at it. So you have a general solution like this. You want y to be bounded, and you observe that this term must be 0, which means C2 must be 0. So what does that mean? C2 is 0, that means this term is just gone, and your solution will have only one term. So you can write out your solution, which is here. So y will exactly equal to C1 times e to the 2t. Now you have one arbitrary constant, C1 here. And we can actually nail it down by one of the initial conditions. That is, y0 equals to 1. By using that, put t equals to 0, we found out y0 exactly equals to c1, right? So because e to the 0 is 1. So c1 is 1. Okay, so this actually gives us the solution. The solution must equal to e to the -2t. And now you can use this piece of information to go back and answer the question. So the question says, what will be y prime of 0? What is this value a, right? So you can differentiate your function, and you get an a, -2 in front, and then you plug it in, set t to be 0, y prime as 0, this shall be your value a, and you find out that it's just -2. So that's the same number we find. It will be the same as the one you would find using the other method, but you might have noticed that this way here it's much easier. Okay, so just would like to point this out to you. Hope this is helpful, and if you shall have any questions, always let me know. Send me an email. Okay, thank you.